Okay, welcome back to the second part of our video. We're going to go through how to solve out this last question on your lesson 8 practice. Okay, so we're going to use Newton's law of cooling, and we're using a forensic science example. Let me rewrite our model really quick. Negative KT. Okay, so our phases. Phase 1 is solve for K. Phase 2, answer the question. All right, to solve for K, basically you need to be plugging in the temperature of the surrounding, the difference of the temperature, and that's like the first part. Then you need a time temperature ordered pair combo, and then the only variable left would be the K, so you could solve for it. So let's see what we've got. We're going to figure out the temperature of the surrounding, temperature of the object, and what we're going to do with these is calculate the difference, surrounding minus object. Oh, I think it's the other way. Nope. Or yes, got to switch that. Temperature of object minus temperature of surroundings. Okay, let's start with that. So, reading our question. A body is discovered in a hotel room. At 7 a.m., a police detective found the temperature of the body to be 85 degrees Fahrenheit. At 8:30 a.m., the medical examiner takes a second reading, of the body's temperature and finds it to be 82 degrees Fahrenheit. The thermostat indicated that the temperature of the room in which the body was found was 74 degrees Fahrenheit. Assuming normal body temperature to be 98.6 degrees Fahrenheit, how long has the victim been dead? Okay, let's see what we can do. So this 7 a.m. time right here, we're going to call this is our start time. It's like when time is 0. So we'll calculate elapsed time, like how many minutes or hours has passed since 7 a.m. Okay, so that means this 85, this is the temperature of the object. Okay, 85. So the environment, excuse me, let's see. So it says at 8:30, the medical examiner takes a second reading to be 82. This here is going to be our time temperature ordered pair. And then the second part, the room temperature, 74. So 74 is the surrounding temperature. So we can go ahead and calculate the difference between those two temperatures. So object 85 minus surrounding 74. So that'd be 11. Okay, I circled the temperature of the surrounding because that's the two things we're going to plug in. Okay, what else do we need? We need a time temperature ordered pair. So right here at 8:30, there's a time and then a temperature taken at this time. Well, we can't really plug in, 8:30. So here's what we're going to do is we need to do elapsed time since 7 a.m. And so 8:30 is 1.5 hours later. I suppose you could do 90 minutes. Either way, I'm going to go with hours. So I've got 1.5 hours and 82 degrees. All right, so we've kind of structured out the info. This is all we need to solve for K. So we're going to plug into our model. So if I do it like step by step, first I'd have temperature is temperature of surroundings, 74 plus the difference, 11. Oh, yeah, object first, just making sure. Sometimes I get that backwards. times e to the negative k times little t. So plug in your time temperature, 82 equals 74 plus 11e to the negative k, times by 1.5. All right, and I suppose you could like skip this initial step here if you wanted to. Okay, guys, we're going to solve for k. First off, subtract 74. So that's going to be 8 equals 11e to the negative k multiplied by 1.5. Next step, divide 11. 8 elevenths equals e, and maybe at this point I'm going to rearrange the exponent so it's a little easier to read. Negative 1.5k. Now we apply the natural log function. All right, we have natural log of 8 elevenths equals negative 1.5k. Divide by negative 1.5, and here we go. So k equals, we'll get our approximation, natural log 8 elevenths over, I just forgot, negative 1.5, negative 1.5. Okay, so I'm going to go to 4 decimals. The more the better, so your answers are more accurate. So I'll use 4, 0.2123. 0.2123. Okay, let's zoom out and see. So all of this is so we can plug k back up to this part. Whoops. Right here. So I do actually like to write this because at the end when I get k I know where I'm supposed to plug it back into. Okay, let's do this. So now let's complete the model over here. Temperature is surrounding temp 74 plus 11e to the negative 0.2123 t. Oops. Okay. All right. What is our question? So here we go. Assuming the normal body temperature to be 98.6, how long has the victim been dead? So how long is implying solve for time. Solve for time. And this 98.6, this is the temperature. So we're going to plug in our temperature for T, solve for little t. All right. We're going to have temperature 98.6 equals 74 plus 11e to the negative 0. Eraser tool. 0.2123 t. So this time, you guys, we're solving for our variable up in the exponent. All right, step 1, subtract 74. 24.6 equals 11e to the negative 0.2123 t. Divide by 11. And I personally just leave this as a fraction because at the end, type it in the calculator anyway, so may as well just save that to the last part. Okay, now we cancel the exponential function with base e. We cancel this with log base e. That's called natural log. Apply the natural log function. Okay, we're going to have natural log of 24.6 over 11 equals negative 0.2123 t. Divide negative 0.2123 on both sides. cancels. And we have little t equal to this stuff. All right, ooh, I drew over the negative. Don't want to forget that. All righty, let's type this in. We have natural log of 24.6 divide 11, divide by negative 0.2123. And this is a time, and we have a negative time, so we got to talk about that. Let's just go to one decimal, negative 3.8. Okay, so what is that even saying? T is negative 3.8 hours, or hours. That was our unit. So cool. That doesn't answer the time question. At what time? So if we recall our question, I guess never mind. It didn't ask what time, but we'll talk about it so we know how the negative makes sense. So how long has the victim been dead? So this negative time makes sense in this context because if I think about like a number line, 7 a.m. was like, let's move this. Okay, 7 o'clock a.m. This is actually corresponding to time 0. This is like when everything first was measured. So the negative time means 3.8 hours in the past, aka, let's maybe write it better, before 7 a.m. So almost 4 hours before. So almost 4 hours prior would be like 3 a.m. And it's just a little bit after that. Okay, so the 0.8, if we convert the 0.8 part, so it's 3 hours and 48 minutes before 7 a.m. Like that would be totally fine. It's a little more descriptive. So what would that be like? 3:12 a.m. All right. So we did a couple of examples, this forensic science example of Newton's law of cooling, and then previously we did an apple pie. Very different situations. All right, guys. I'll catch you later. Take care.